So, as Sherry mentioned, this is a NIST consortium project, which includes our NCCoE team of security experts and 14 industry collaborators, which is a project that we launched back in March of this year to support the directive outlined in Section 2CI of the Executive Order 14306. The main objective of our project is to demonstrate security practices that align with the NIST Secure Software Development Framework to basically improve security at all stages of the software development lifecycle, all the way from a piece of software's initial planning and testing to its deployment, operation, and maintenance in real-world environments. So in short, on this project, we are demonstrating DevSecOps practices consistent with the NIST's Secure Software Development Framework. So that's, in a nutshell, that's what the project is about. To demonstrate the relevant security practices, we are considering two types of cloud-based software development environments, one being the closed source and the other the open source. And our project's initial focus is cloud-based closed source software development environments, which is why it's highlighted in yellow on this slide. Additionally, to complement the security practices that we're demonstrating on this project, we're also sprinkling in some AI capabilities to basically demonstrate how to leverage them securely in these types of environments throughout the phases of the secure software development process to automate builds, integrations, deliveries, and deployments, which essentially obviously lead to faster software development. And last but not least, we're also demonstrating how to take advantage of zero trust security capabilities to elevate security postures even further in these types of software development environments. So this is the timeline for our project with respect to the progress that we achieved thus far on the project. But the left side of timeline, which is in red, represents actually two zero trust efforts that we conducted at NIST and NCCoE. In 2019, we ran a year-long zero trust research project and produced the NIST SB 800-207, the ZTA document, which we published the final version of in August of 2020. And then in 2021, we launched a consortium, a ZTA demonstration project to demonstrate how to deploy ZTAs using that guidance. And between July of 2021 and December of 2024, we successfully demonstrated and documented 19 example zero trust architecture implementations using commercially available technologies contributed by the collaborators participating on that project. So the reason it's on this slide is because in this project, we're repurposing our zero trust security knowledge and expertise to demonstrate how to elevate the security in these types of environments with application of zero trust. The right side of the timeline portrays basically when we launched the project, what we have accomplished thus far. For example, after we officially launched the project, we were initially busy with the infrastructure planning. And after we got done with that, with the support of our industry collaborators on the project, we started provisioning cloud-based environments, infrastructures, technology onboardings, integrations, etc. In parallel, we've also been focused on project's main deliverable, which is an 1800 series NIST special publication, which we refer to as Practice Guide. We were able to publish our first preliminary draft in July, which basically provides an initial high-level overview about the project. But of course, in our future releases of the document, we will include a detailed reference model along with specific implementation guidelines for each of the project's planned use cases. So this is our latest notional reference model that we're using to demonstrate DevSecOps security practices. One observation that you might make is that this one looks different than the one that we shared in the high-level document that we published in last July. And those of you that reviewed that document will certainly notice a different look. But that said, this one just looks different. In fact, it still portrays, captures everything that the other one did. So from the perspective of what it includes, it's the same. The reason we decided to go with this version is because it portrays everything more from the perspective of continuous DevSecOps lifecycle, and everything that it touches under that realm throughout each phase of software development. That includes CI/CD pipelines, SSDF, Zero Trust. And so that's really the only difference. Otherwise, both versions are correct. But going forward, we will use this one because it seems to be more in line with our project's objectives. So this reference model represents a typical DevSecOps lifecycle that most of us are familiar with. In fact, it also shows the sequential stages that characterize the software development process. In DevSecOps, there's a concept of control gates, which sometimes people refer to as security gates, which are basically automated checkpoints as part of orchestrating automation mechanisms for continuous builds, continuous integrations, continuous deliveries, and deployments, which we typically refer to as CI/CD pipelines. These control gates, which are illustrated by yellow gear icons in this model, enforce security policies. They perform checks before the software development process can be allowed to proceed to the next stage of software development process. And so these gates basically stop any activity that doesn't meet the security requirements in place to prevent insecure code from continuously advancing to the next stage in the software development process. And as an added benefit of this controlled automation mechanism, which, like I said, enables continuous builds, integrations, deployments, we're also able to collect continuous feedback captured through the control gates, which can potentially inform the earlier stages of the DevSecOps to influence positive changes in the process, which is essentially the shift left mechanism to basically identify and address issues proactively as early as possible in the process. The continuous improvement security monitoring is basically a set of persistent services and activities that basically engage in all phases of the DevSecOps practices as a layer. They basically provide ongoing monitoring, security assessment, management of systems, applications, and management of infrastructure throughout the DevSecOps lifecycle. The layer of secure software development framework in this model simply represents the implementation of the security practices we are demonstrating in that framework as they are applicable throughout the DevSecOps lifecycle. Finally, the Zero Trust environment layer basically represents the Zero Trust security capabilities that we will harness to impose least privileged access within the entire environment as an overarching security model. One final comment that I would like to provide before moving on from this slide is that this diagram and the subsequent ones that I will share with you next were created with the guidance and deep expertise of our team's security engineers, as well as our gracious industry collaborators participating and supporting the project with their expertise and their technology contributions. So this is the result of that collaboration. So the next diagrams are about each phase of the DevSecOps lifecycle. I will go through a couple of them only, but then I'll share the rest of them very quickly for the interest of time. So the plan phase in DevSecOps is where we define security requirements, do threat modeling and risk assessment. In most software developing organizations, this involves cross-functional teams collaborating to identify potential risks, design secure architectural choices, and develop a strategy for implementing and testing security controls for software development. On this project, for the plan phase, what you're seeing on this diagram are the activities and components that we think should be included. Our goal here is to basically take these activities and then the components that enable those activities and map them to the groups and tasks in SSDF. In this case, for the plan phase, we believe we can identify mappings to SSDF tasks and prepare the organization, produce well-secured software, and respond to vulnerabilities groups in SSDF. The develop phase in DevSecOps is where teams across software development, operations, and security employ security practices basically directly into coding practices by, of course, following secure coding guidelines and best practices to prevent introducing vulnerabilities. They use pre-approved tools to build features, integrate security, ensure quality, and verify artifacts before moving them to the next phase of the DevSecOps process. Some of the activities mentioned are coding, analyzing code, conducting automated scanning of code for vulnerabilities as the code is being written, running automatic checks prior to committing code changes to source control repository, about storing, tracking, and maintaining sensitive information, etc. And of course, again, same thing applies here in this phase. These are the activities and components that we think should be included in the develop phase. And our goal is to map those to the groups and tasks in SSDF. In the develop phase, we think that we'll be able to map some of the tasks in all of the groups in SSDF. So I'll just go through this fairly quickly. Again, this is the build phase. And this slide basically shows all the components, activities that we're considering. This is the test phase. So same thing applies. Basically, all these activities and components that we're considering and for this phase and that we're going to demonstrate and map the outcomes to basically the tasks and groups and tasks in SSDF. Another phase, a release phase, the same thing applies here. This is a diagram that lists all the activities and components. This is the deploy phase. Same thing applies here. In this case, we believe that we'll be able to map to some of the tasks in all groups in SSDFs for this phase. Operate phase, same thing applies here. Project's main output, the main deliverable on the project is NIST Special Publication 800-44, as I mentioned before. And we anticipate publishing the next preliminary draft release right around November, sometime in November 2025. So this is, if you are interested in more information about the project, there's on this slide, we are sharing the link to our project's webpage. And also, if you have any questions that you'd like to reach out to us with, you can use the email alias provided in this diagram. So this is how you would connect with us.